are you?
What's the smell?
Coffee?
Okay. Yeah.
I don't know.
I had coffee. My advisory assistant here.
No, it's coffee.
Brody, she won! I would bet money on her winning.
Yeah, I knew it. Second one.
Or Campbell.
It was in alphabetical order.
It was mine. But honestly,
E, I forgot to
so you should
Oh my
know.
god.
Well,
Band. By the first person.
But you wouldn't know if she was queen or
yeah, you knew she was top 2 immediately.
because
Because she said her last name. Wow, that was, I should have worn this shirt. It's a lot of work. I can't imagine, like, I would have a full-blown panic attack if I had to do that. Dance in front of the school, and then sit in spot, like, there's,
Yeah, I think it would be kind of fun.
it would be fun though.
It's like,
Sorry.
like
Next year.
no one should
No,
say
I-
that because
no, I
everyone
asked
should
for
be
it.
rated younger. And younger.
I don't know why.
You're right, but like, someone who's unbelievably uncoordinated and can't dance.
Yeah.
Like, so was Augusta, and she did great.
Yeah, it's like you can like.
You can fake it. Yeah, you can fake it. They actually did good dance. I was vibing. I recorded it.
Oh my gosh. Wait, that's so cute.
Actually,
This
it's
is
funny.
the sweet Christmas tree.
Yeah, that's what I thought.
And they like changed it at the last.
Oh, I should have like girl scooter.
I was gonna bring my Chromebook to record it. But
I mean, like, but like, just I don't know why they made it or that was like a year
yeah.
I know, I felt like a photographer. Look at her, she's so cute.
Ruby's so cute.
Oh,
See her sister?
her bawling.
Bowling.
I would too. Kate, like a lot of people were crying. I don't know, we were crying last time.
Okay, if I didn't get your 23 last class, please bring that to me before we get started here. So we've got one last piece with vectors. So next week we will have a review day and a quiz. Brody Slade, Olivia won't be here. Nora should be here. Okay, so assignment 24, the last piece of vector stuff has to do with motion. So position to velocity to acceleration and speed. And all right, so let's go ahead and take these notes so that you can do this assignment and be checked off. So, position, velocity, and acceleration. Again, I think that this would probably work out the way you expect it to. So, position. Any guesses why they call it R of t instead of S of t or X of t? I don't know the answer, but I just have a guess.
Because variables are used.
That's not my guess. What does a vector look like? A word that starts with R.
Array.
Right. I think it's because vectors look like array, they probably do R, but that's just my guess. I don't know. But if you have a position vector, you can take the derivative of the two parts to get his derivative. Now remember, the derivative of velocity or position gives you velocity, same as we did last year. And then you can take the second derivative of position to get acceleration. So derivative of position gives you velocity, derivative of velocity gives you acceleration. Nothing new there. But the speed, what does this notation mean?
Absolute value. Or wait, no. It's
Yeah, it looks like absolute value signs.
magnitude.
Right, this means magnitude. And magnitude is like the length. So when we have a vector, just use this as an example. When we break it into components, like if this is a velocity, so you've got so many, whatever, let's say feet per second. When you break it into a component form, it's like you know the horizontal speed, how fast is it moving right or left, and the vertical component tells you how fast it's moving up or down. So if you want the speed, it's the magnitude or length of the velocity vector, which is the same thing as this. So because this makes a right triangle, you essentially just do Pythagorean theorem where you use x prime and y prime. So square rooting, one of them squared plus the other one squared. And again, but you do have to make sure you realize it's x prime and y prime that you need. So I'm going to highlight this because I hope you remember these first three. I hope that's nothing new to you, but that speed one is a little bit new to you. So question one, or example one, has us doing a little bit of all of this. If we are given this position vector, we should be able to find the velocity vector, we should be able to find the speed, we should be able to find the acceleration vector, any of those things that it asks for. So to go from position to velocity, just take the derivative. So derivative of this, don't forget chain rule here, would be cosine of t over 5. Actually negative cosine of t over 5. Check by doing the derivative, or I'm sorry, I am doing the derivative. Never mind, I'm doing derivative. So that would be sine something is cosine something times chain rule would be times a fifth. So the 5 times a fifth just becomes a 1. And since I'm taking the derivative, I don't need a plus c. We only need a plus c when we're integrating. Okay, and then the derivative of cosine is negative sine. And because of chain rule, this would create a 1/5. So 1/5 times this needs to yeah, I'm sorry. I'm still trying to integrate in my head. Okay, are you guys okay with that? Okay, sorry, I'm trying to overcomplicate it, I guess. All right, acceleration vector, they also ask for, so just take the derivative again. Derivative of cosine something is negative sine of something times chain rule. The derivative of sine something is cosine something times chain rule. So there's two of their three answers. And then finally speed, this formula up here. It's the square root of the derivative of r, which is the same thing as v. So if you have that, that's ready to go. So derivative of this right here. This is where I already took the derivative. So I would like to square that plus y prime, which I've already taken over here. I'll square that. Okay, now I'm not going to write any more out, but if I've got over here, I've got sine squared of t over 5, and over here I have cosine squared of t over 5. What is sine squared of an angle plus cosine squared of an angle? 1. Doesn't matter what the angle is as long as it's the same thing. Sine squared plus cosine squared equals 1 as long as it's the same angle. So the speed is just 1. So of course that's different than velocity because all I know is how quickly it's moving. I don't know anything about its direction. Velocity would be where you care about direction, whether it's moving right or left or up or down. Okay, so again, other than where I was kind of stumbling, position to velocity to acceleration. Do the derivative and probably use chain rule. Try not to do antiderivative though. That's what I was trying to do in my head. But speed, got to use this formula that looks like quadratic formula. Okay, and then more review. So for a particle to be speeding up, velocity and acceleration need to have
The same sign.
that is correct, same sign. So both positive or both negative. We talked about that last year. If velocity is positive, it's going to the right. If acceleration is positive, it means it's speeding up to the right. If velocity is negative, it's moving to the left. And if acceleration is negative, it's speeding up to the left. So it's speeding up. You can speed up to the left or right, but your signs need to be the same. Velocity and acceleration need to have the same signs. And of course, then if they have different signs, they're slowing down. So if velocity is positive, I know it's moving to the right, but if acceleration is negative, it's speeding up to the left. So I might be moving to the right, but the rate of change is decreasing. Okay, so I don't know how example 2 is much different than example 1, but if we are given position, we can find velocity and acceleration by taking the derivative once for velocity and twice for acceleration. If we would like to know the speed at a certain time, we can use the speed formula. That looks like Pythagorean theorem. And then I'll do speed at t equals 2. Okay, so it's something like something squared plus something squared. Does this look right? Why not?
You didn't take the derivative.
Right. You either need to be using the velocity function components or the derivative of the position, which are the same thing. So this is really just supposed to be a 3 This would be e to the negative t times chain rule, which would be times another negative 2t. And if I square that, negative 2 squared. Actually, I don't know. I don't want to do that yet. I don't want to do too much arithmetic that I missed the question. Because remember, I'm going to come in and plug in 2 for t anyway. So.
Wait, is okay. Never mind.
That's a 2. That's a 2. So it looks like the speed is going to come from the square root of 9 plus. Now be careful not to just call this 3. You can't take the square root of terms. You can only take the square root of factors. You can't just take the square root of 9 and then add and then hope this works out also. So I've got the square root of 9 plus this would be negative 4. But if I square that, that would become positive 16. This is e to the negative 4. And if I square that, I get e to the negative 8. Wait, that doesn't sound right. Oh wait, here's the square. Okay, so this would be why am I trying to square this twice? What am I missing here?
You start with e to the t squared. So you have to square it twice.
So that would be, oh, I'm sorry. I wrote it down right and then I did the exponent rules wrong. When you multiply things with the same base, what do you do with the exponents?
Add.
Add. And I was trying to subtract there, I think. Actually, that may not have been the problem, but it could be. Let me make sure that this gets the same answer. Okay, this works. I have a mistake on my paper, but I didn't plug it in the calculator to make sure that I got the same thing they did. That's right, but as a decimal, you could throw it in the calculator, and it would be something like that. So, not a hard formula to use, but be careful. You might want to write this out a little bit bigger than I did, so make it a little bit easier to keep up with this mess. Okay, so I feel like the speed formula requires a tiny bit of memorization, but there's one more formula in here that if you want to know the total distance traveled, that's like integrating the magnitude. So if this, we have up above, speed, this is another way to say speed. If you want to know the total distance traveled, you can integrate the speed, and that will tell you how the distance changes. Remember, when we integrate things, it tells you how the function below it changes. So if you integrate the magnitude of velocity, it's like giving you the change in the function below it, the total distance. So we're still going to use the speed formula. That looks like Pythagorean theorem. But for total distance, we need to add all this up. So we would integrate that from a to b, and then the variable should be t, so dt. Okay, so let's look at an example of that, and then talk about how to know if it's moving right or left. And what is part ice? What is that supposed to say?
You're missing an L.
Yeah, they have a typo in there. It's supposed to say particle. I mean, I get typos on my papers too, but I don't share mine with thousands of people. So. Okay, question 4, or example 4. Here's a velocity vector, and we know the position when we start is at 1, 2. Find the position at times 3. What is the total distance traveled from 0 to 3?
Where's the typo?
They didn't spell particle correctly. It's on the bottom of page 1. It didn't matter, but I just thought that was strange. They've never noticed. Okay, so we have velocity and we want position. What do we have to do to a velocity function to get a position, or not function, a velocity vector to a position vector? What do we have to do? Right, so let's integrate. So R of t, integrating 2t plus 1 would be t squared plus t, plus there could be a constant, so let's put plus c1. Integrating 5 would be 5t, plus there could be a constant, let's call it c2. Now we can use this point to solve for C1 and C2, because this is supposed to be the position vector. So t squared plus t plus C1 is supposed to be 1 when t is 0, which means C1 is 1. And then when t is 0, the vertical component of position should be 2, which means C2 is 2. And now I have the real position vector. It's the vector that goes through the point 1, 2 when t is 0. Notice if I plug in 0 for t here, it now clearly goes through 1, 2, so that's good. And if I take his derivative, it still gives me the velocity vector, so I'm still on the right track. Okay, and then we are asked to find the position at t equals 3. So I should be plugging in 3 into which vector? Which vector is going to give me position?
It would be R.
R. So 9 plus 3 plus 1, comma, 5 times 3 plus 2. So at 3 seconds, or 3, I don't know, whatever the time unit is, that's where it is. And then what is the total distance traveled from 0 to 3? So at 0, it started at 1, 2, and then it went to 13, 17. But you can't just say it was at 1, 2, and then it's at 13, 17. You can't just find this distance because there's probably some curvature to it. So we need the total distance traveled. We need to add up all of these values. So total distance traveled, that's the formula we did on the bottom of the front page. It is just basically integrating speed. So we're going to integrate from 0 to 3, square root of v squared the derivative of position, or v, same thing. We already had v, so why not just use it? Here's x prime, here's y prime. And this one doesn't look too bad, but I do know the answer is a weird decimal, so that would have to be a calculator question. So again, you can't just say, I know the point it started at, the point it ended at, let me just use like the distance formula or something, or connect them and do Pythagorean theorem. That's not good enough because we don't know that it's a straight path. We don't know what's going exactly from that point to the other point. Okay, anything in 4 that you're concerned about?
Could we have just done that the whole time, basically?
Well, it wanted multiple things.
Oh, it wanted the position and okay.
Yeah, it wanted more than one thing, so yeah. All right, and then finally, last example. If we know the velocity function, how are we supposed to know when it's moving to the right or when it's moving up? So, with particles in AB, when was something moving to the right?
When it was positive.
When what's positive?
When the velocity is positive.
Okay, so when velocity is positive, but we've got a vector. So is it when the first part's positive or when the second part's positive?
The horizontal one. Yes.
Right, if you care about right, that's a horizontal measurement. So we should be looking at the horizontal component. The horizontal component tells you if it's going left or right. So I need to figure out when is the velocity positive to know when it's moving to the right. So set the horizontal component, the only thing that affects left and right, make it greater than 0. Or you can try to set it equal to 0, but then you have to test to see what's going on around it. So we could divide both sides by 2. Inequalities solve just like equations, except if I multiply or divide both sides by a negative, I have to switch the inequality sign. I don't know. Y'all know how this is going to finish? I think this is easier to think of from just a number sense standpoint. E is a positive number. So E is not much different than the number 2 or 3. It's between 2 and 3. Is there any exponent you could put on 3 that gives you a negative number? You might be tempted to say something like -1, but remember, if you make this negative, all it does is it moves the 3 to the other side of the fraction. So this guy is always, well, I say always. During these times that they care about, this guy is always positive, so it is always moving to the right. There's no value of t that makes velocity negative. And then if you understand that process, then B is just doing the same thing with the other piece. When velocity is positive, it could be moving up. When velocity is negative, it's when it's moving down. But if you're talking about a vector, you should be focused on the vertical component. The vertical component's the only part that tells you if it's going up or down. And so if I want it to be going up, I need that to be positive. So make an inequality and then solve that. Multiply both sides by t plus 5. Add 4 to both sides. Do I need to switch the inequality sign here? Because I never multiplied or divided both sides by a negative. So when time is greater than 4 is when it is moving up.
Why did we get rid of t plus 5? Oh wait, because we add multiple.
Yeah, I just multiplied both sides by t plus 5. On the right side, 0 times anything is still 0. So, or you could think of it as this. The only time a fraction is greater than 0 is when the numerator has to be greater than 0. If this is negative, then it's going to make the whole thing negative. Okay, so there are 1 or 2 formulas on the front page that I feel like maybe not super intuitive, the speed and the total distance traveled, but the position, the velocity to acceleration, or acceleration to velocity to position with derivatives or integration should all be familiar. Speeding up versus slowing down should be familiar. So I don't think you're going to struggle too much with this one, but that's all the examples, so go ahead and try a few out before lunch. We got about 20 minutes, so I don't know. Hopefully, you can get 4 to 5 done. And I can't find my copy from last year, so I need to rework these also. So. pretty smooth at first. I've already done the first 8, so there's not too much to a lot of these. Okay, guys, if you would, please try to finish up the handout that we started before lunch. If you do finish it, please turn it in so I can grade it and get it back to you. If you run out of time, you're welcome to still get full points at the start of the next class, but I think you'll have enough time. The stuff that I did before lunch, again, I couldn't find my copy from last year, so I started reworking it, and I did everything except question 16 before lunch, so. And I only started on it after you started on it, so.